This video covers SOL A.3, so I can put a square root in simplest form and I can put a cube root in simplest form. Alright, quick review. When we're simplifying square roots, if it's not a perfect square, we're going to break it apart into factors. One must be a perfect square. So one of your factors has to be a perfect square. When you have variables, even numbered exponents are perfect squares. So if you don't have an even number exponent, then you're going to have to break that apart. If you do have an even number exponent, you take the square root by dividing the exponent in half, and then you're going to simplify as much as possible, take the square root of all perfect squares, and leave everything else underneath the radical. So here is our first example. I have 48, a to the 16th, b to the 25th. 48 is not a perfect square, so I'm going to break it apart into the perfect squares. The biggest perfect square that goes into 48 evenly would be 16. So I would have the square root of 16 times the square root of 3. In my variables, a to the 16th is already a perfect square. And then b to the 25th, I'm going to break apart because I need an even number exponent. So b to the 24th times b. Now I'm going to go through and simplify. The square root of 16 is 4. The square root of 3 can't be simplified. The square root of a to the 16th is a to the 8th. The square root of b to the 24th is b to the 12th. And the square root of b cannot be simplified, so whatever's left over stays underneath the radical. So I have 4a to the 8th, b to the 12th times the square root of 3b. When we're doing the cube root, it's the same thing, so I'm going to break 135 apart so that one of the factors is a perfect cube. So it will become the cube root of 27 times the cube root of 5, because 27 times 5 is 135. Then I'm going to simplify what I can. The cube root of 27 is 3, and then the cube root of 5 cannot be simplified, so I have 3 cube root of 5.